Welcome to our video on multiplication, tricks and methods. This whole video is designed to make you a stronger mathematician. And the reason being is I've worked with many different students, many types of learners, and some that are very, very quick at math, they enjoy it, they find it easy, and some that struggle a little bit. And one thing that's always going to help is if you practice your multiplication and have a variety of methods to use. Now, this video does assume that you know your 12 times tables, and we'll be working on that assumption. So I'm going to discuss 3 tips and tricks and also 3 different methods. I'll be actually starting off down here with one of the methods, partitioning. So we're going to start off with partitioning, and the reason is I think this is a very, very valuable skill that not many students use or utilize. So the original thought behind this whole video was actually a partitioning video, but then I quickly realized that these are a lot of the tricks that my students have given them an aha moment, and I actually use a lot of these. By the way, I have a degree in maths and I still do all of these techniques here that are simple and broken down, and yes, I write things down as I'm calculating. I advise you do too. So once we've done partitioning, we'll be looking at compensation. Then we'll be looking at something called doubling and halving, followed by multiplication by factors, which isn't really a well-known method, but I've spoken to other teachers that say it's really useful. And when you're at this level, you have a great understanding of maths, and this really is a good exercise to help build that. If you want to use simple numbers, you could use 1-digit and 2-digit numbers, and this will really help you. What I say to students is, to understand your multiplication and times table, you should be identifying factors of numbers, and this exercise gets you to do both, find factors and multiply. Then we're moving over to grid method. Some of you might know, a bit similar to partitioning, but bit more of a formal layout. And lastly, column method. I know there's lots of videos already out there on column method, and I know it's taught a lot to a lot of students. Personally, I'm not a big fan of it. I much prefer the partitioning, but I want to include it and I want to go through it, and I'll discuss it a little bit later. So let's start this off with an easy to use example. Let's look at a single digit number, 6 times 14. Some of you might be able to do this one already. Some of you might need to use the partitioning method. I can write this as 6 times 10 and 6 times 4. Well, what have I done there? I've took 14 and I've split it into 10 and 4. Here I can work out what 6 times 10 is, 60. Then I can go ahead and work out what 6 times 4 is, and that'll be 24. Next, all I need to do is add these two numbers together. So in this column, we've got just 4s, 4. In these two, 6 and 2, this gives us 80. So the reason I like this method is all we've done is broken down and used a digit from each column. We've gone ahead and done a multiplication that we're capable of, got the answers, and then added them together using column addition. Nice and straightforward. So now let's look at some other examples. If you have a good understanding of what we did here, then you can go ahead and have a go yourself at finding out what we'd partition these into and even answering them. I will have some questions for you to do after this. This is still the explaining section, but you can go ahead and pause right now if you want to. Right, so let's look at 7 times 23. How would we split that up? Well, I'd split the 23 into 20 and 3. So I'd do 7 times 23. Sorry, I'd do 7 times 20 and 7 times 3. Well, 7 times 20, so we normally do 7 times 2, which is 14. And then add the 0 at the end. Well, put the 0 at the end. 7 times 3 is 21. Now just notice, one thing I'm really mindful of is the columns I'm using. So I'm making sure all my units go here, my tens here, and my hundreds here. Go right, my answer, 161. Next, this question here, 13 times 44. This is interesting because where do you do the split? Where do you split these two numbers? It's quite an interesting conversation, and most students try and split 44. But if you partition 13, you can do 44 times 10, which I hope most of you can do, and then 44 times 3. Considering this is just 3 times 4, add 3 times 40, we should be able to do that level of partitioning in our head. So this here is 440. Now 3 times 40 is going to give me 120. Add 3 times 4, which is 12, which means my answer will be 132. Here, I can add all these together to get my answer. What you could have also done is, if you're not confident with this, you could have actually gone ahead and just done 3 times 40 equals 120, and 3 times 4 equals 12. And then tallied up like this. 2, 7, and 5. So 572. So far we've done 1 digit times 2 digits. We've done 2 digits times 2 digits. And let's have a look at 1 digit times 3 digits. Now, as you can see, I've had to change this back just because of space. And you might be thinking, this is actually quite, this takes a lot of space. It's a lot of writing. So let's have a look at how we can actually simplify the amount of writing that we have to do. Instead of writing in full mathematical sentences like this, what we can go ahead and do is look at 143 and break it down. 140 and 3. Now, what we can actually go ahead and do is do 6 times 100 is 600. 6 times 40, well, 6 times 4 is 24. So we're going to put the 0 at the end, 240. And 6 times 3, 18. Now we can just tally these numbers up as we have been, like we were over here. 8, 5, 8. There we go. We have our answer, 858. The reason I wanted to introduce you to this is because sometimes my students resist partitioning method because they think they have to write all of this out each time. You actually don't have to. You can just go ahead and do something like this, and even when you get quicker, you might not need to write the numbers down individually. You might just be faster at doing it. Identify 6 times 100, 6 times 40, 6 times 3. List them out, and we're done. Moving on to the next question. Here, we're lucky that this 2-digit number is 11, because 11 is a classic partition where we times something by 10 and then add 1 more on. And we're going to be using that technique here. What I'm going to do first is what I did in the last question and break this down. So 11 times 300. Well, let's have a look. 10 times 300 is going to be 3,000, but we need to add another 300. 3,300. 9 times 10 is going to be 900, and let's add 90 on top of that. 990. We should know what 2 times 11 is, but 2 times 10 is 20. Add the 2, brings us to 22. Now we just add up as we have been with column addition. And that gives us 2. This is 11, 1 here. Carry the 1. 1 and 9 will give me 10. So we've got a 3. carry one more. 1 and 4, 1 and 3, sorry, gives us 4. 4,312 is our answer. Now we just discussed how useful it is to use partitioning with 11 and how quickly we can do it. Just before I give you some example questions to do, I would like to show you how to do it with 15, because this is a really common one we do all the time. 15 times anything. Well, what we're actually end up doing is 10 times that number, and then we half our answer and add them together. So we do 10 times something, we half that answer to get 5 times that number, and then we just add them together. So let's take any number, 7. Yeah, 10 times 7 is going to give me 70. I don't even need to think about 5 times 7. All I need to do is half that, 35. And here, suddenly, we have our answer, 105. Voila, nice and easy. This is really, really useful for certain numbers. 15 is one of them. So, as promised, I have a couple of questions for you to try. Here we have 7 different questions. These ones should definitely be manageable using the partitioning method we've outlaid here. And these are a little bit trickier, but I want you to have a go nonetheless. So please pause the video, and we are going to show some of the answers in 3, 2, 1. So before jumping straight to the answers, I thought you might appreciate a breakdown of the numbers. Here you can see 85 is 80 and 5, 29 is 20 and 9, 77, 70 and 7. This one you might have tried to do differently. You might have tried to break down 39 into 30 and 9, which is absolutely fine. But for me, the more practice you get with this, I see it might be a little bit easier here. 10 times anything requires absolute minimal thinking. Here we've got a 3-digit and a 1-digit, so I split this into 440. Here I have all 3 columns occupied by non-zero numbers, so I've had to break it into 300, 340 and 3. Over here I have 4 columns occupied by non-zero numbers, so I've had to break this down into 1,890 and 2. I'm going to lay out my multiplications for you, and then you guys can see if you've got the same thing before we check the final answer. So go ahead and check your multiplications. I don't want to show you the answers and you're not sure where you went wrong. You can pause this video for as long as you want to check your multiplications. These here get a little bit more confusing on the red line. Up here, this is nice because you're just doing 7 times 7, 49, and moving across a column for 70 times 7. So please just take a look and make sure that you have either something similar or the same, or if not, you know, oh, it's my 7 times table that were difficult. You might have found your 9 times table difficult. This helps you to identify where you need to improve on. So pause now before I show the answers in 3, 2, 1. So here are the answers, guys, and just take note after you've done marking. Just take note to see how much attention I have paid to lining up my digits and my columns, and I've done that because of the addition, and it just helps when you're carrying ones over. I've shown that as well, so you can check your working. But over here, I've not been too neat, and I carried 1, and it actually slowed me down. I nearly made a mistake. So please try and keep your lines as clear as possible. It will help. So congratulations if you managed to get the hang of this, especially these ones here. But if you got these ones right as well, fantastic. I know everybody might not got onto these as they are a little bit difficult. Let's have a look at the compensation method now. This is a really, really useful technique for any calculations when you're multiplying a number that ends in 7, 8 or 9. But to kick us off, what we're going to do is first we're going to have a look at just 2 single digits. Let's do 9 times 6. Some people find the 9 times table comes easy. I personally, for many, many years, including throughout my degree, was doing compensation method, where what I would do is I would write 9 in my head as 10 minus 1. I'd then go ahead and times both of these numbers by 6. So I would end up with 60 minus 6. 60 minus 6, 54. Voila, I have my answer. This is a bit of a simplified version, and it is better to use it with 2 digits, but even on 1 digit times 1 digit numbers, this is really, really good. Let's have a look at 9 times 8. Again, what we're doing is 10 minus 2. 10 minus 1, sorry, times by 8. Here, this is going to be 10 and 8 is 80. And then we just do minus 1 times 8 is 8. Oh yes, my answer is 72. So here we have an example with a 2-digit number and a 1-digit number. I've got 2 examples here. I'm going to advise that you pause it for a second before I show you how I lay it out before I work out. Have a go yourself. So we'll be back in 3, 2, 1. So here we go. I split 17 into 20 minus 3, and 68 are represented as 70 minus 2. Let's go ahead and do 3 times 20. 60 minus 3 times 3 is 9. What's my answer going to be? 51. 6 times 70, well, 6 times 7 is 42. We'll put a 0 on the end. 6 times 2, there we go, going ahead of myself there. 6 times 2 is going to be minus 12. So 420 minus 12 is going to give me 408. Hopefully you got something similar. If not, not to worry. We have some practice questions for you to do. So here's your next set of questions. We've only got 4, but what you can do is go ahead and pause the video, use all these, use the notes from here. Hopefully you've made some yourself. But use these notes to try and work these questions out. And I'm going to lay out the calculations in 3, 2, 1. So before I move on, I'm really sorry. I wrote one of the questions from here on here. Here, number 2 has changed to 2 times 37. Please pause the video now. So here's how I break it down and calculated it. Hopefully we are ready for some answers. 180 minus 6 is going to be 174. 80 minus 6 is going to be 74. It's just a coincidence. 900 minus 9 is going to be 891. 350 minus 7 is going to be 343. There we go. Let's move on to our next method. But before I do, I want to be clear, it is okay if you skip out this step here. And in your head, you're just going straight to this. That's fine. Don't expect you to write out your working in full every single time. But if you, as you do it, you just jot down the numbers you're thinking of, it will make things easier for you. So let's have a look at this double and halving technique. Here's two sums I'm going to use as an example. We have 25 times 12, and we have 12.5 times 16. Let's just make that a little bit more prominent. So how do I use this technique? Well, I'm not a big fan of doing 25 times 12. But what I could do is I could double one of the numbers and half the other. So 12's even, I can half even. I can half 12 to be 6. 25, I can double it. You can double any number. You can double it to be 50. So 50 times 6. Now I'm more confident to do that one. And if you're not, we can go one more time. Half this number, 3. And this number, we can double it. Ends up being 100. 100 times 3, 300. Our calculation became much, much simpler just because we doubled one side and half the other. We're always going to get the same answer as long as we're doing opposites to one number and the other number. Here we have 12.5 times 16. So I'm going to keep going with this one a little bit. Double 12.5, we get 25 times half this, 8. Let's keep going. So if I just keep doubling and halving, I can get right down to my answer, 200. Now it might have been that this is the point where you felt comfortable. You might have felt comfortable here or here, or even down here. It doesn't matter. This technique is great for certain numbers. But in particular, at least one of the numbers that you are using this on, the halving number, should be an even number. Now let's have a look at doing some questions to practice this. So here's some practice questions for you. You've got these top 4, which is the same technique we have been over here, doubling and halving. Down here, I've included something a little bit different. By timesing by 3 and dividing by 3. That's an ampersand, by the way. It's timesing by 3 and dividing by 3. The reason I've included this is quite often my students ask me, so is this possible? And yes, of course it's possible. It's not as useful, but it can be done, and sometimes it does actually make the calculation easier. I've picked some specific questions for this one. So pause the video and have a go. I'll be back with some answers in 3, 2, 1. So this is how I doubled and halved. And I wanted to outline, if you've got anything that's 2.5 times, so anything ending in 0.5 times anything, and the other number is an even number, please double and half. It's going to make it so much easier. 5 times 7, 35. Just these two, look, there's a stark difference. This one is much easier. Here, if one of your numbers is 5 and the other one's an even number, again, please double the 5, because 10 times anything is relatively easy. Here, again, ends in 0.5. Let's double this, half this, and we have 4. Right, let's move over here where we've got something in 2.5. We can only do this if our number over here has a factor of 4. And that's what we're looking for when we say even. When we say an even number, it means it has a factor of 2. So this here has a factor of 4. So I can double and half. I can double and half again. And this becomes quite easy, 75. Down here, we've got our timesing by 3 and dividing by 3. And these actually only work if this has a factor of 3, and again this also has a factor of 3 in it. And here the reason I showed you partitioning first is because I'm going to go ahead and use partitioning. 3 times 6 is 18, 3 times 60 will be 180. 9 times 9, 3 times 3, sorry, is 989. Fantastic. Over here, I'm going to employ partitioning method again. And I'm going to do it the other way around just to show you it can be done either way. 6 times 60 is going to be 360. And here, 6 times 600, with just these numbers, but a column moved along. Okay, and now we can add these up. We've got 3,960. Hopefully you guys got something similar. Let's move on to our next technique, which is multiplication by factors. So I was looking at the length of the video and I thought this would actually be a good time to take a break. We've gone ahead and done partitioning, we have done compensation, and we have done doubling and halving. I'm going to split this video into 2 parts because I feel like we've got to a point where this is quite a bit of work and I don't want you guys to lose attention. Before I go, I just want to point out that I think the next video might be a little bit quicker because partitioning was the method that I really wanted to dive into. I'm hoping some of you have got the hang of it and it's going to help you out in the future with your calculations. Grid method is similar, but multiplication by factors is really what you should be coming back for in the next video. And